leaving in less than a...
Why do we need toilet seat covers? One word, Tennessee.
Okay, antenna fans, it's K8BYP with some interesting news. I've made a new antenna. I've never seen or heard of one like it. It is an end fed. Believe it or not, I spend a lot of time here dumping on end feds, but that's because of the improper attempts to match a transmission line to the end of a wire, which is impossible. And I explained that in my how to make end feds and verticals work. There's no way with any kind of gimmick whatsoever to couple energy into a single point at the end of a wire. It will not happen. So what I've done here is I've made it's not quite a quarter wave for 15 meters, but it's close, to dispense with the myth of it must be a half wave. And if I can get the thing poorly as it's made to be stable long enough to get measurements, I can dial it into almost any resistance from about 20 ohms to about 100 within a couple of megahertz. About 20 megahertz up to 22 something. So it's, with one setting, it may not be as broadbanded as the dipoles are, but it's adjustable. I can go to the feed point and twiddle and diddle and get any resistive reading I want across this frequency range. That's highly unusual. It's poorly made at the moment. There are some bad connections at the feed point, and that leads to a problem of, I'm here on 21076. The band's pretty much dead. I can just barely hear some digital signals, but I'm going to key down. In fact, I'll go down just a hair. I shouldn't key down where there's known traffic. But this is reflected on the bird watt meter. And when I key it down, due to poor connections, we should see initially a lower power reading. Then after a short time, fractions of a second maybe, it should jump up a little bit. But this is reflected power. That's interesting. There isn't any. Let me change slugs. Apparently my last matching attempt got the SWR down to almost nothing. That was the goal. It was reading about 50 to 60 watts forward and maybe 5 to 7 reverse. But let's see if the meter does that jumping up thing after a short key down. You see it climb up. That's caused by bad connections. That can happen in a coax connector, at an antenna connection, any place in the system. But the fact that it starts off low indicates that the antenna is proper to start with. But there's a bad connection that's oxidizing, and that oxidation can be extremely bad. You see, the reflected power went up from barely readable, maybe a half a watt, up to 2 or 3 watts with just a short key down. So that's not good, but I know why that is. But so the forward power is about that much. 50 watt scale, center scale, about 19 watts. So 19 out, 1 back. That's pretty good. That's enough to operate. Problem with an end fed can be that if it's compared with a dipole here, the dipole is 2 quarter wave arms, and this particular end fed I've built is half that. So we might expect, excuse me, considerably less received signal. And there's really nothing on for signals, but we can hear the noise here. This is on the end fed. That's on the dipole. A fair increase in noise. Don't know if you can hear the digital signals, they're very weak. But there's the end fed. That's not really enough difference to make any difference in copy on CW or phone. It might be decodable on a digital format, but that's not a fair comparison because that can retransmit and do error checking and all that. So let's go out and take a look at this new antenna. Okay, outdoors in the domain of antenna cat, wherever antenna cats run off to, there's the LMR 400 low loss coax coming up to the support cord. I hope you can see that. And going to the end of a wire. Oh my goodness, somebody hung their laundry on this. Yeah, the laundry's hung there because I'm not going to show you what's in this at the feed point. That's my secret. It is unusual. And then the wire, proving it's an end-fed wire. There it is. I didn't cut it to quite the length I wanted, so here's how to extend it. Clean the ends off, wrap some smaller wire around it, just solder the thing. So I just added 6 or 7 inches on. But air conditioner, nice thing to have in Tennessee this time of year. That is an end-fed. It is a quarter wave. And by making adjustments at the feed point, I can match it R50 exactly. No Baluns, Ununs, clamps, tuners, or other magical, mythical crap that hams and some engineers falsely believe are useful to couple to an end fed. They don't work. What you're making with any of these networks is a parallel network, and they're extremely lossy. Parallel circuits have very high circulating currents. So about all's being accomplished there, and the 20-meter vertical in the background the same way. I can take the pole off with just the I can go up 4 feet and take off the so-called antenna, and what's left still operates. I get a 1.3 SWR, but nobody can hear me. But if we put a tuned circuit or a ferrite transformer at the feed point, the energy is mostly being dissipated at the feed point, not out the wire. And for a practical proof of that, notice on the air as conditions are declining, you don't hear stations with end feds on the air anymore. So there it is. It's been done. I've got to perfect it. It's very clunky right now. It's a mechanical kludge, so I got to fix that. It just won't hold tune, so to speak. But I know exactly why. And once I get that done and find the exact values at the feed point, then I'll use engineering math to calculate forward into what is the characteristic of the antenna itself. So there it is. My little end fed. KBYP did it. And a couple of important end notes inside where it's cool with Family Guy on pause. At 4:15 in the video, the 2-position switch has the larger cable on the lower left. That's the LMR 400 to the end fed. The cable in the upper right is the cheap low loss RG58, about 3 dB worth of loss gone to the 15-meter dipole. The 2 antennas, the end fed and the dipole, are roughly in the same space, same height, pretty much same everything. The end fed is fed with a low loss, maybe about 3/4 to 1 dB, I don't know exactly. The dipole is fed by probably about 3 dB worth of loss. And note, at least in a quick receive test, the signal on the dipole was noticeably stronger, even through maybe another 2 dB loss. So that might go to show the effect of having the end fed, which is only half the length, on receive. Perhaps if the end fed was also about halfway overall length, that might change. But there are going to be problems with that. that's quite likely to result in a mismatch. On transmit, in theory, maybe it doesn't make any difference. Either the energy is all emitted or it isn't. What's it really matter in the space of 11 or 22 feet if the pattern's the same? What's it really matter if half of it's off one wire and half of it's on the other? If you go up a mile, if you travel just a mile away, you can't even see these Mickey Mouse antennas. They're so small. So what difference does it make in 1, 10, or 1,000 miles? It may not make much difference. So that would leave a question as to what's the value of an end fed really? Is there really any? Well, it doesn't have a heavy feed point in the center, so it's going to be easier to keep it straight. There's one advantage over a dipole. And with the idea of getting as short an antenna as possible, especially for portable or mobile, there's a shortened antenna, and it's no big deal to put a 5 or 10 dB receive amplifier on. So mismatch on receive doesn't really matter. It can't damage a receiver. And I really shouldn't have used the cheap low loss RG58. I just happen to have it. The LMR 400 original from Times is, I think, probably about $1.50 a foot by now. An outfit going by Jefa, Jefa Tech online, had a clone for, I think it was 60 cents a foot, and I've used both. They both work fine for my purpose. So there's a really no reason at that point to use a cheap RG58. So a couple of important points. Did it.